Hello everyone, welcome to the second lecture session, online video lecture session. In the last class, we had discussed in detail a DC regulated power supply. We had seen its definition, why we need to go for DC regulated power supply, and where all it is being used, and the factors affecting that are the ill effects of the uh, unregulated DC power supply, and we had ultimately seen the basic block diagram and its working of a DC regulated power supply. Now in today's session, let us discuss the rectifiers. It is a continuation of a DC regulated power supply. Okay. Under this particular heading, we are going to see the definition of a rectifier, various parameters that rectifier is associated with, different types of rectifiers, and in that, one of the type is half wave rectifier. We will see the definition of a half wave rectifier, and it's finally we are going to study its circuitry and the circuitry working. Okay. So before the rectifier, before we further move into it, we will first understand the what is rectifier. Rectifier we already have discussed in DC regulated power supply. So what it is? It is nothing but a device or a circuit which converts AC input to DC. This we came to know in the last session itself. Hence, I have moved directly to the parameters of a rectifiers. Okay. Uh, in this slide, the first parameter associated with the rectifier is ripple factor. While discussing in the DC regulated power supply, I had stressed that the output of a rectifier is a pulsating DC. So it is not a pure DC, it is a pulsating. Pulsating in the sense it is composed of AC component, larger amount of AC component present in it. So it is called as a ripple factor. Ripple is nothing but a noise associated with the output of a rectifier. So it should not be there. So therefore, ripple factor signifies, it's a quantitative measure. It signifies the amount of noise associated in the rectifier output in the form of a AC component. So it is a unitless. It is defined as the ratio of RMS value of AC component present in DC output to the average value of DC output. So generally the question is asked in examination, define the ripple factor, and you have to just write down as a, it is defined as the ratio of RMS value of a AC component present in the rectifier DC output to the average value of a DC output. So here the rectifier is a unitless, and this parameter should be lesser and lesser for a better performance of the rectifier. If its value is more, then it is an indication of a not a superior or a efficient rectifier. Hence, it is a measure of a noise or a amount of ripples associated in the rectifier output. It should be of a lesser value. Hope you understood what is ripple factor and its significance. Now moving to the next parameter, very important parameter, rectifier efficiency. So rectifier efficiency, again we know that efficiency is a parameter used to show the quality of a performance. When even explaining one individual personality, we say that the person is more efficient to do this or that. So it signifies a positivity of the circuit. So more the efficiency, better the performance of the device or a rectifier. So hence it is given as the ratio of DC output power delivered to the load to the AC input power from transformer secondary. That is, it is simple, in a simple sentences we can define as any output ratio of any output to the input is called as a efficiency. Here what is the output? It is the DC power to be delivered to the load. What is the input? Input is nothing but a AC input from a, we are getting from a secondary of a transformer. Hence this is called as a, this is how we are going to measure the efficiency of a rectifier. So this is the efficiency, a measure of performance of rectifier circuit. It is always measured in a percentage. Again it is unitless. So now moving ahead to the next parameter, that is peak inverse voltage. It is nothing but it is the reverse bias voltage in a rectifier circuit that diode can withstand. Its unit is volts. It means that we know that all the rectifiers make use of a PN junction diode. PN junction diode in any rectifier acts as a basic rectification process. It is a main device that converts AC to DC. Hence, diodes plays a very important role in this rectification process. It is the diode's capability that it can withstand the reverse bias voltage. So hence it is defined as, because it's been driven by a sinusoidal wave. Sinusoidal wave continuously getting up every half cycle, it changes its polarity. So first half cycle if it is positive, second half cycle it will be negative. During negative cycle, the diode gets reverse bias, and we know that the PN junction diode should not be given the higher reverse biased value, otherwise the device will break down or will get damaged. So hence it is the, that care should be taken in the rectifier circuit. It means that if all the devices, we know that when you see any, buy any component or any light or any devices, there will be given some specifications or a operation ratings of a that particular device, current withstanding capability, voltage withstanding capabilities, and other associated parameters. Some ratings will be given. Like that, all the diodes, different types of diodes based on their dopants and the manufacturing rating, each of them have a different power withstanding, voltage withstanding capabilities, reverse bias voltage withstanding capabilities. So here let us not bother all those things. We should just get to know that PIV is nothing but a peak inverse voltage or a reverse peak reverse voltage or a reverse bias voltage that a diode, which is acting as a rectifier in a rectifier circuit. So it is the diode's reverse bias voltage withstanding capability, reverse bias voltage handling capability of a rectifier circuit is called as a PIV. So it is related to the voltage. What voltage? Reverse bias voltage. Hence its unit is volts. It is measured in volts. Hope you understood ripple factor, efficient rectifier efficiency. peak inverse voltage, and ripple frequency. So here ripple frequency is nothing but it is the frequency is nothing but number of cycles per second. So it is nothing but a ripples are nothing but a harmonics what we are getting AC component in the output of the rectifier. So this AC component present in output of rectifier is derived from the AC input. Hence it will be possessing or consisting the same frequency as the AC input. So it is represented by F naught. Okay, these are the uh, four primary parameters of the rectifiers which plays very important role in design or in functionality of a rectifier. Okay, next moving to the what exactly a rectifier. We already know this. We repeated this terminology. We quite oftenly we are listening to it from the first session. I don't think it needs much explanation here. For the and again for understanding purpose as a slide is there, so let us first again have a small discussion over it. Rectifier is a device or a circuit which converts AC input supply voltage into DC output voltage, and the process of converting AC into DC is called as a rectification process. The rectifier output is generally in a pulsating DC form consisting of a higher amount of AC component in it called ripples. So if the question is asked you like what is rectifier or define rectifier, you are supposed to write this much. This much is sufficient for that particular question. Okay, next moving on to uh, the types of rectifiers. There are basically three major types of rectifiers, that is half wave rectifier, center tap, full wave rectifier, and a bridge type full wave rectifier. Okay, the uh, type of rectifier we are in detail discussing in this session is the half wave rectifier. So again it is nothing but it is a rectifier which converts AC to DC. That is that applies to all types of a rectifier. Irrespective of the type of the rectifier, all the rectifiers primary function is to convert AC input voltage to the DC output voltage. So is the half wave rectifier. It is called half wave rectifier because it allows only one half cycle of an AC input voltage blocking the other half cycle. So what it is doing, why the name is so called half wave rectifier? It is converting the AC input to DC output voltage, but for how, what cycle of an AC input? For only one half cycle of an AC input. It may be a positive or a negative depending upon the output power we require. If we require a positive power DC voltage, the polarity we connect in the circuitry is different. The PN junction the way the PN junction we connect in the circuitry varies depending upon the positive DC voltage requirement and a negative voltage negative DC output voltage requirement. So half wave rectifier is nothing but which conducts only for a one half cycle of the AC input voltage. It is not in one cycle of AC input we are going to have one positive half cycle and one negative half cycle. So half wave rectifier will not conduct for both the half cycles, but it is going to conduct to any one half of the AC input at a time, while blocks the other half of the cycle depending upon the type of the circuitry. And why it is so? It is so because half wave rectifier makes use of only one semiconductor PN junction diode. We know that from our basics of semiconductor devices, we know that PN junction diode conducts when it is forward biased and allow the current conduction or allow the current to pass through it. When it is reverse biased, it won't allows the current to pass through it. Hence, it is called as a unidirectional device. So, single PN junction semiconductor device is used in half-wave rectifiers. It is called as half-wave rectifier as it conducts for one half and blocks for the other half. Okay. Now, this is the circuitry and waveforms of a half-wave rectifier. So, from circuitry, it is very clear that it is making use of a AC supply input, AC source, which is supplying 230 volts AC input voltage with the 50 hertz frequency. This AC input is supplied to the transformer. The transformer from a figure, it is clear that it is a step down transformer with a primary and a secondary winding. Secondary windings are having lesser windings compared to the primary winding. By seeing the picture only, we can say that it is a step down transformer. Okay. The secondary of the transformer is connected to the S1, which acts as a during the positive half cycle. S1 will be positive, S2 will be negative. So, considering the positive half cycle, S1 is positive and S2 is negative. It is connected to the P of the diode. Diode D is a PN junction diode connected in series with the load resistor RL. So whenever it is asked write a half circuitry for write and explain the half wave rectifier, you are supposed to write this circuit along with the waveforms. So in order to understand the operation, let us see that AC input voltage is supplying 230 volt 50 hertz AC input to the transformer. We already know that from the last session discussion, we came to know that why we supposed to use transformer, what is transformer. Once again I'll repeat it. Transformer is nothing but a static electrical device which converts which transfers energy from input circuit to the output circuit. It is consisting of a primary and a secondary winding separated by a core. Core may be made up of any type, iron or a copper core or any type of a core. So here primary is represented by P and secondary is represented by S. The upper side indicates P1, S1. The lower side indicates P2, S2, just to represent the polarity of a AC input signal. So 230 volts transformer also isolates the output load from the input circuit. Hence it acts as a protective device also, protection to the load. So now in order to understand the operation, let us see that 230 volt 50 hertz AC input is supplied through the primary coupled through the primary of the transformer to the secondary of the transformer, output of the secondary of the transformer. During the positive half cycle, I am explaining with respect to the waveform. During the first positive half cycle, that is 0 to pi value, it is called as a positive half. During this positive half cycle of a secondary of a transformer, a PN junction diode is connected in such a way that P is facing the S1 and N is facing the S2. It means P is anode, N is cathode. So for positive half cycle, the S1 will be positive and N will be S2. N is connected to the S2, that is negative. Hence P is positive, N is negative. Just recall the basics of the PN junction diode. It's nothing but for the positive half cycle, PN junction diode is forward biased. We already know that PN junction diode, when forward biased, allows the current to pass through it because it is acting as a closed circuit or a closed switch. So hence positive half cycle, first positive half cycle is coupled to the load from the secondary of the transformer. Hence the load current flows in the direction S1 D RL back to the S2. This is the direction of current flow during the first positive half cycle of AC input. Hope you followed this. Okay, now the cycle of AC input is changing its polarity when it reaches the pi, and it is reversing its direction from pi to 2 pi. That pi to 2 pi we call it as a negative half cycle, and hence during this negative half cycle what is happening? Just think of, recall the positive half cycle what I had explained. In the positive half cycle, S1 was positive, hence P is connected to positive, N is connected, S2 was negative, N is connected to negative, diode D was forward biased. Now when for the second negative half cycle of AC input, sorry, not second, the other negative half cycle of an AC input, other cycle or a negative half cycle of an AC input, what is happening? S1 becomes negative and S2 becomes positive. It is as good as P connected to the negative of the battery and N connected to the positive of the battery. What happens during this condition? This condition P given to the negative, we call it as a reverse bias of a PN junction diode. Hence, during this S1 negative and P2 negative with respect to PN junction diode is called as, or the PN junction diode gets into reverse bias condition. Reverse bias condition, we know that what happens in a reverse bias condition? Due to increase in a depletion region of a, or a junction, the depletion region of a PN junction diode, the diode is not able to conduct the current. Even if at all it conducts, that is due to the minority charge carriers present in the diode, that too in terms of a microamperes, which is negligible, hence it is considered almost as a open circuit. Hence during the negative half cycle of an AC input, PN junction is a acting as a open switch. When PN junction diode is acting as an open switch, this negative half cycle is not coupled to the load. So that we can very clearly see in the waveforms, output waveforms. We can see that, isn't it? For 0 to pi region or 0 to pi time, the positive half cycle is coupled to the load. From pi to 2 pi, it is 0. The output voltage is 0. It is very clear from the waveforms. And again when the from negative half cycle to again it is progressing, the AC input voltage is progressing towards the positive, next positive half cycle. So during again this next positive half cycle, what is happening? S1 is becoming positive and S2 is changing its polarity to negative. Once again diode is getting into what? Diode is getting into forward biased condition. Hence what it is going to do? Again it is going to act as a closed switch. Hence it is going to couple or transfer the apply the pass the load current through the RL back to the secondary S2 of the winding. Hence this is how the what the load current passes through the load resistor for every positive half cycle, and it blocks or zero current flows through the load resistor. That we can very clearly see in the, for all the negative half cycles there would be a zero current through the load resistor. So hence, as it is conducting, as the circuit is conducting only for the positive half cycle and blocking for the negative half cycle, hence we can conclude that half wave rectifier conducts only for a one half of cycle of a AC input, blocking while blocking the other half of the AC input. We are converting only half cycle of AC input to the DC voltage. Hence, it is called as a half wave rectifier. Hope you have followed neatly the operation with respect to the circuit and the waveform. Okay. With the discussions we had just now on the rectifiers, let us discuss few questions, multiple choice questions over the same topic. Okay, the first question goes like this: half wave rectifier circuit makes use of how many diodes? Option A 1 diode, B 2 diodes, 3 C 3 diodes, or 4 diodes. Yes, yes, it is half wave rectifier. Just now we finished our discussion on half wave rectifier, and if we recall the circuitry, there was only one diode, PN junction diode, the half wave rectifier used. So the answer is therefore A. It is one diode rectifier. Now the half wave rectifier conducts for A. only positive half cycle and blocks the negative half cycle, or both positive or a negative half cycles, or either one or both the cycles of AC input, or all of the above. Okay, the circuit we have just now discussed. So, okay, tell me the answer. Yes, it is as it is consisting of only one diode. So, with respect to the circuit diagram we discussed, it conducts for a only positive half cycle and blocks the other half cycle. Hence the answer is A for this. Okay, moving to the third question. The efficiency of a rectifier circuit is defined as the ratio of. I already discussed this efficiency of any circuitry or a device, or just in a general way, efficiency is nothing but output to the input, any output to input. So here, what is output? Output is DC. You should always keep in mind that any, maybe it is any kind of rectifier, output is DC, input is AC. So if we consider voltage or a power, we should use the, again if you change the voltage and current, that changes the answer, changes the definition. So here efficiency of a rectifier circuit is defined as the ratio of DC output power to the AC input power of a secondary of a transformer, or DC input power to the AC output power of a secondary of a transformer, or AC input power to the DC output power of a secondary of a transformer, or all of the above. Okay, it is the output in a rectifier is what? It is AC or DC? It is AC. What is the input to that? It is AC input. Hence the answer is A. DC output power to the AC input power of the secondary of a transformer. Hence the answer is A. Okay, now the ratio of RMS value of AC component to the average value of DC output is known as dash. Yes, very simple question. In the parameters topic we had discussed this. Is it efficiency, or is it PIV, or ripple factor, or none of the above? Yes, RMS value of AC component to the average value of a DC output. It is the, by just seeing the terminologies in the question itself, we can make out it is the ripple factor. So definition of ripple factor is nothing but ratio of a RMS value of AC component to the average value of a DC output. Okay, the last question of the session we are going to discuss. The ripple factor of a, for a half wave rectifier is, okay, let me tell you. Here I had not mentioned or not discussed the ripple factor parameter or efficiency parameter. Here with this question only I will explain this answer. So the ripple factor is the amount of AC component present in the DC output. So hence it is the measure of amount of ripples of, present in the DC output. It is a ripple is nothing but a noise parameter or a noise quantity. Again, which is the indicator of a performance of a rectifier, how good the rectifier is. So just tell me whether the ripple factor is more or less for a good performance. It should be less for a good performance. For rectifier circuit, the ripple is 1.21. Hence the answer for this is 1.21, that is D. Sorry, I had forgotten this in a discussion. Okay. And I would like to tell that when we discuss the efficiency, so efficiency again is an indicator of the performance of a rectifier. So efficiency should be more or less for the rectifier circuit in order to call it as a better rectifier or a good rectifier. Yes, of course, you are right. Efficiency should be more. So when efficiency is more, we can say it as a good rectifier. So the efficiency for a half wave rectifier is 40.6 percentage. Keep in mind, half wave rectifier efficiency is 40.6 percentage and the ripple factor is 1.21. So with this we come to an end of the discussion. Just would like to recap the topic once again. Going back to the, I just stay in this slide because with this slide alone we can recap all the things we had discussed in this. Firstly, again I want to in a very short I would like to explain in one shot. Rectifier is a circuit or a device which converts AC input voltage to the DC output voltage. And there are various parameters associated with it. such as ripple factor, efficiency, PIV, and ripple frequency. So ripple factor is nothing but it is the ratio of RMS value of a AC component present in the DC output to the average value of a DC output. So ripple factor for a half wave rectifier is 1.21. Keep in mind it is 1.21. Then coming to the rectifier efficiency, I repeated it many times. Any DC the DC power delivered to the load is a ratio of DC power delivered to the load to the AC input power from the secondary of the transformer. So you should keep in mind when you go to the questionnaire, you should able to answer. So hence efficiency is a measure of a better performance of a rectifiers. So efficiency is good, rectifier is good. So but for half wave rectifier it is, as it is making use of only single diode, efficiency is reduced here as because of a only half cycle is utilized, half cycle of AC input is getting wasted. Therefore wastage in the sense that much energy is being lost or a loss of energy. So hence therefore efficiency is lesser. The value of efficiency of a half wave rectifier is 40.6%. It is measured in percentage. PIV is nothing but a reverse or a inverse voltage, reverse bias voltage withstanding capability of a diode in a rectifier circuit. It is measured in volts. So ripple frequency, again it is the output, the frequency of the ripples or harmonics in the AC harmonics of a AC component present in the DC output. So it would be same as that of the AC input, but it is for a only half cycle. Hence the frequency is same as that of AC input, that is F naught. Okay, we have seen types of rectifiers: half wave rectifier, full center tap full wave rectifier, and a bridge rectifier. And any rectifier that makes use of a single diode and converts or conducts only for a half cycle of a AC input, and while blocking the for other half of the AC input is called as a half wave rectifier. And we have seen how the rectifier works with respect to the waveforms. We have seen its operation. For positive half, diode is conducting. For negative half, diode is reverse bias, hence not conducting, hence no load current. So zero load current, we can clearly see that in the waveform. Again the same cycle repeats and the same load current is repeated as for the first cycle. So this is how the rectifier works. The DC output, rectified DC output shown in the output voltage is going to appear for the AC input. Okay, with this recap and repeated explanation, I would like to stop here. This is the end of the session, and thank you for listening. I would like to again extend my heartfelt thanks to the team. Thank you so much.